Hello, welcome back to my workshop. This video is about this, my MiSTer FPGA all-in-one retro wedge shape case. So let's have a look at what I've made. The idea was inspired by an Amiga A600 that somebody had done this very thing in, and they'd got a case. They used a keyboard modification from Time Off Software, so they could use the original Amiga keyboard as a USB device. And then they had all a manner of extensions and wires and stuff. And I'll show you a few pictures now. So this is the original project. We have the Amiga 600 with the MiSTer and all the various extension cables. And here we have the adapter from Time Off Software that takes the keyboard inputs and converts them to USB. So you can see that he's pretty much got everything covered inside the case, and it's really tidy. And then he's just got ports available on the normal Amiga 600 ports on the back. So he did a really good job. But the cost of that was an Amiga case, much like this one that I brought. I think this was about £30, but it didn't have a keyboard. None of the clips worked in it. So this was going to take quite a lot of work to get it up and running. And then you had the cost of the Amiga keyboard and the Time Off interface to convert the keyboard to USB. So we were getting up to quite a lot of money. But I like that idea of that shape and keeping into that style. Your other option is to use some kind of ready-made case. And in this case, Neil from RMC used a Checkmate 1500. He matched it with this really nice black monitor, keyboard and speakers. And you have to agree that it looks really good. Here we can see the leads that he used and the case. Inside we've got all of the extensions, and they go to metal brackets on the back to break out all the cables. I highly recommend that you go and check out the two videos in the series where he makes this if you're interested in doing this kind of case, to see some of the problems that he solved, like the power switch and the cable breakouts. It's a really good watch. So I did a bit more research, and what I found was the Project Julia, which is a 3D printed design to emulate an Amiga 600, and that uses this keyboard that was in here. I think this is a 60% keyboard. I could be wrong. I'll put the details on the screen. If we have a look on the Facebook page, you can see some better pictures of prints that people have done. So it can look nice if you're prepared to put the time in. And then after buying it, I spent close to 2 weeks printing parts for it. And there are a lot of parts. So this is the front, then you have the back, and then there's the part that goes in the middle. So these all need printing and gluing together. You then have this part that goes on the back, and then that part goes over the top, like that, and then this keyboard will go inside there. It's designed really nice. The examples that I've seen, it looked absolutely amazing. But I was really not happy with a few details of this. One, it was only set up for the Raspberry Pi, so I still needed to do some modding. Two, everything was printed face down. So you can see if you haven't got your first layer set up, you'll get all sorts of blemishes and marks. Most people would have to print it like this in sections, and then you have to sand it and prime it and paint it to get it to look good. I'm lucky enough to have a printer that can print it in one part. Everything was just such a long time to print because of the way that it's printed. Like all of these parts at the bottom are all printed on supports, which adds to the time. And then all of these parts on the side are also on supports. So you can see how rough this is. And then after all of that, the amount of time that it would take to sand it and paint it and prep it to get a good finish. Now, if you're into that kind of thing, this is a really nice design and I highly recommend it. But I'm not. I really don't have a setup to paint and prep and sand. I hate painting and sanding to get a good finish, especially if you use PLA. PLA just doesn't sand very well. So you'd want to use something like PTG or ABS, which adds to the difficulty of printing, and also I don't like the smell, it irritates me. So after printing all of this, the amount of time that it would take to get this finished to an acceptable level where you're looking at these parts all the time, it was just too much for me. I didn't want to do it. So my idea was to take the basics of that and keep it as simple as possible. So all of these parts are printed with the base down so that you can have a nice surface finish. You can print these in whatever settings that you want to print them at. I also did pause and change the filament, so I've got a nice colour change on there. All the parts are modular so that you could change the front to suit a different keyboard, or you could change the back for a different type of small computer. I'll show you later where I've got one section that can be used for a Raspberry Pi. This can still be printed on anything like a Prusa or an Ender. I printed them on an Ender 3. So this was the first one that I did, and this was quite a nice print. This is printed in Prusa Pearl mouse, so it looks really nice. And I spent quite a long time doing this, and it was okay. But then as I was developing and trying this out, I just didn't like this keyboard. People were asking about other types of keyboards and having the flexibility. And this one limited the size of the keyboards that we could have without changing too many parts. I did a bit more looking around and I found these Tenkeyless keyboards. And I liked the layout of it. You've got the function keys and the cursor keys. It's not too cramped. It looks more like the size of a classic computer. And I decided to redesign that first one to this. So the same design principles, it's easy to print, minimum supports, and the parts that you see on the top will look nice because they don't have all of those issues from the first layer. So the keyboard just rests in the top and everything is just screwed together. If you wanted to, you could glue it as well, but the screws just make it easy. And again, because it's modular, you could change the parts that go on it. So this is the part for the Raspberry Pi. So I think the next thing that we will do is we'll just look at the actual assembly of this. And then after the assembly, we'll get it set up and we'll give it a try. So these are the parts that I printed for my modular MiSTer case. 2 parts at the front for the keyboard, one side for the MiSTer, one side for the USB hub. And then we have the tops that go on. I also have another option, which is for a Raspberry Pi 3. So that would just replace that back part. I made a little cutout section so the keyboard can go through and loop round to the side where the USB ports are. It's made so that it all screws together with these same size screws for the most part, and then just some shorter ones for these sections. I highly recommend that you use a really long screwdriver to help with this. We slide them together, you pushed it in to a certain point, and then tighten. So that's the front part. So this is where having the long screwdriver comes in, because you can get through the gaps on one side. Okay. And now we just put those 2 parts together. You don't want to over tighten anything when you're screwing into 3D printed parts, because we don't want to split anything. Parts across there, and then there's screws that just hold the top parts together. And I don't know if you can see on that one, it's a bit wobbly. And what I think would be better would be to glue this. And then these two parts here, which have got slightly shorter screws. So that is our base, and even without the glue, it's quite sturdy. There's options for the base. You can do the hexagonal shape, you can just have cutouts, or you can do it solid if you want. It was just, for me, it was doing the cutouts was a lot quicker for prototyping and used a lot less plastic. Looking at the time on the slicer, this was no different to doing a full base, but it does save some filament, and I think it looks cool as well. So we've got a cutout just there, and then like your keyboard would loop around. We need to put some brass standoffs in here for the MiSTer to screw into. And then the top pieces go in with the same screws that we used for the sides. Well, we'll save those until we put the MiSTer in. So that is our base. So I'll get the parts and we'll put the MiSTer inside. So this was my rough prototype, and you can see where I've printed it without any kind of care about quality. We've got holes because I printed it with just one top layer and one line. The total time to print the nice case was around 72 hours. I started printing early in the morning and left it running, generally finished around about midnight. So these parts were about 13 hours. The tops were 8 hours, and this front section was also around about 13 hours. I printed at 0.2, reasonable quality. I found this really nice filament, matte forge. It's a matte filament, and you can see that it looks really, really nice on the side. Hardly any layer lines at all for a 0.2 print. But I couldn't quite get the top to print without some marks. This one I didn't have the cooling set right, so there's some like marks from the cooling on the smaller sections. But they came out good enough that I'm going to just stick with them until I decide to spend a bit more time and tweak it a bit more. So we just need to take these out of here. The way that I've got it set up is I soldered a power lead to go from the MiSTer to the USB hub. I found that just to be the easiest way. I'm using one of the original USB hubs and one of the older I/O boards, so I don't know how this will work with newer versions. You might need some tweaks. Here you can see the buttons that I glued onto the tactile switches, which go through the top and poke out these holes so that you've got an easy way to access the buttons. So that is the OTG lead that goes to the hub. I put in an extension for the LAN port, and also have an extension for the, I can't remember what it's called, but the low latency game adapter on the side. And then on the back, everything just screws in. The USB hub is just in with those self-tapping screws again. So that's the USB hub, and it's a version 1.1. So the MiSTer is in with brass standoffs into the plastic. So we want to keep these brass standoffs in place. So I'm just going to put them back through to the bottom. And you can see there where I've soldered the power leads on. And now we want to get the brass standoffs out. Right, this is our new one. I'm just going to screw one of the screws back in. And then we can use that to get a thread going. Okay, so that's the standoffs in. So this is a little bit tricky to get in if you're going to have this adapter on the side. And you have to like get the adapter in. And the switch as well. That's in place. Okay, so that's the MiSTer secured. So there's a few things that I don't know about, and obviously there's a few different types of modules. I made this for myself, so I've modeled it around this exact unit. So there could be some tweaks that need to be made for the various different types of I/O boards and USB hubs and memory configurations. So the USB hub just goes in with those self-tapping screws. Then we plug in our power. The USB goes to the OTG on the side. Then we have our Ethernet extension. I also left room for the micro, or is it the mini? Anyway, the USB that's also on there, I think, which is used for debugging. So there's room for that as well. So like I say, we have the SOG, switch, micro SD, and the second micro SD on the I/O board, and then the ports on the side. The USB hub. So this is what's called a Tenkeyless keyboard. It doesn't have to be this one. I think a lot of them are quite generic in size. This just fits in just like that. I did again model it for this keyboard with the various bits underneath, but I think anything should fit. And the idea is that this part goes in the middle, and you just have to get like the cables flat, and then the keyboard plugs into one of the internal USB ports. So it's just a matter of doing some cable tightening inside, and I haven't really done anything about holding the cables down yet. So maybe something that I need to just look at is a way to hold the keyboard cables down. But then I don't really know what cables are going to come with the keyboards. One of the other keyboards I had a detachable USB, so you could put a really short one on and it was out of the way. And as you can see, I've put on some custom keycaps just to make it a bit more retro. I really would like to get rid of the Teknet logo on the side, but there we go. So now we can put the top on. And again, it's just these self-tapping M3 screws. So this side, I put some holes in the top, and I've glued on these little posts onto the switch of the MiSTer. And then they just poke through. And we have easy access to the 3 buttons. So the last thing that I did was left this part for a badge, and I wasn't sure which way to do it. So I had a friend, Robbie, who had orange filament, do me Galaxy Black with orange, and then orange with Galaxy Black. But I'm going to go with the Galaxy Black and orange. So we'll just use a bit of super glue. So there we have my completed system. If we look on the back, I used 69-degree supports so that it was only in these holes, and none of these edges had supports on them. So they look nice and clean. There's no supports that you needed to clean up. And as you agree, this filament really does do a good job of hiding the print lines, and the matte grey kind of adds to that element of it being a retro system. And then the details on the keys, rather than it being just the plain black, adds to it as well. Because this is just a generic Tenkeyless keyboard, you could buy whatever colour keyboard that you wanted. There's so many different styles out there. So the flexibility of you printing it yourself in whatever colour that you want to print, and then buying a keyboard in whatever colour that you also want, just means that you can personalise this however you might want it to be. Then having options to change the modules, so we could put a Raspberry Pi in there. This is quite a typical Logitech wireless keyboard. We just pop that out. You'll see that that also will fit in there. It won't fit now because that cable's in the way. So you could use a wireless Logitech keyboard if you wanted to. If you had a full-size mechanical keyboard, this is just an example, then all you would need to do is print out an insert that would go between these parts, the back parts and the top. You could extend it however wide you want it to be, and then they would just screw in the same. So the flexibility of the design is there, so that you can change it with ease to suit different types of keyboards, different widths. So that's that. I guess really we need to hook it up and take a look at it. Got everything out on the bench that I want to use. So we have my system. I've got a power switch and a heavy duty power supply. I recently bought this Fight Stick MD6, which is a Sega Mega Drive 6-button controller, and I bought an adapter from MiSTer Joystick, and he was really helpful, and we reprogrammed the firmware so that it's always Mega Drive. The original version, you had to do like press some buttons to tell it that it was a 6-button controller. So now we forced it to be always 6-button, and it works really well. I've been using VGA for the screen recently after trying to get as many cores working, and it was okay on the CRT via RGB, but a lot of the arcade cores are twisted, so you couldn't get them on, and the 486 program wants VGA. So having a VGA screen is definitely the better option. I am waiting for an older 4.3 screen rather than using this wide screen. But anyway, let's just get everything plugged in. I have some simple speakers that are just USB powered. And we just use the VGA cable out the side. So it is a little bit of a problem having the things out the side. It could be designed to twist them round, so it would have to be, that would have to be on that side, we'd have to have it longer on the back. So it's doable, but the way that I've got my setup at home, this is perfect the way that I've got it now. So yeah, we've got everything plugged in. Let's just plug in the power. The fan that I've got in here is really noisy. I haven't bothered to change it yet. So we can see that the keyboard works okay. And then we've got the 3 buttons on the top. So reset. And then to get into the menu options. And the joystick is also working. And that's working as a 6-button joystick. So there we can see Amstrad and everything's okay. And we can do F12 to get back to the menu options, or we can press the button on the top. And the bottom button is like an internal reset for whatever core that you're in. So we can go back to the top. Atari 800, BBC Micro, Commodore 64. I think that's just set up for widescreen. Load a program. And this is the Pac-Man that I wrote myself for the Commodore 64. And then we can get into some of the more advanced systems. So Atari ST. Commodore Amiga. So like I say, running on VGA, a lot of the arcade cores are rotated because they're in upright cabinets. But VGA means that we can use the scalers of the MiSTer to keep everything rotated. So as much as I like having the CRT, I found having VGA is a lot better for running it. I'm looking to get a smaller CRT, maybe to go with it, or a multi-scan. So as you can see, it's all set up. It's really easy to use and I'm really pleased with it. Hi, this is Lee from quite a few weeks in the future. I was stuck at home in home isolation and also had lots of work to catch up on. So I haven't really been able to finish off things in this that I wasn't happy with my initial video. One of them is that you'll notice this different monitor. And I was waiting for this to come in while I was filming the other one, and it was a few days later. But now it's set up, and I really like that it's a 4.3 older LCD, and it's grey, matches the colour of my case that I printed. And when it's working on VGA, it has a really nice picture. So now that I've got that monitor, that's going to stay with this when I take it home. This is quite useful. It's got SCART, it's got VGA, it's got S-Video, composite. So a really useful screen to have for many retro projects. Next, in the video, I talked about I wasn't sure of compatibility between the I/O boards and the USB hubs. While I've been at home, that's one of the things that I actually looked into. So here we can see the board that I have in, which is, so this is a version 5.5. And then I ordered one of the very latest, and there's actually no difference in the layout between the versions of the I/O boards. So I know that my case is compatible with all versions of I/O boards apart from the digital version. And like I said, the later version of the I/O board is exactly the same, so there's no need to worry about that. This is my older USB, which is version 1.1, and you had options of where to place the power jack, and you could put it on the side or on this side. So for me, I've got it on the inside, and I used this cable to connect the USB to the OTG. My power lead is soldered onto the bottom of the MiSTer. So that does mean that you're going to have to be happy to solder wires to the bottom of the MiSTer and make up some kind of lead to connect from the header to the OTG. So this is the latest version of the USB. So that's 2.1. So on this one, it has a micro USB port, and I think you get like a dongle that you clip onto that, which connects up to the MiSTer board. So you might not have a cable to do that. This is the same header that's on there, so you can easily wire up a cable that goes to the OTG port. When it's in this way, the power is on that side, and you can see that I've designed the case so that it's a universal, so you can either have it that way or you could have it that way. So that doesn't matter which way that goes in, those USB ports are the same either way. So the decision that you've got is, do you want to copy the way that I did the power? So have it so the power is on that side, have an internal power jack which is soldered onto the MiSTer, and then, because that USB will be on that side, make up some kind of lead that goes from the internal header to the OTG? Or do you want to have it this way so that the power is on the outside, and then you could use an internal USB to OTG lead and then use some kind of external power splitter that will go outside the case over to this side of the MiSTer? So they're the options that you have. This obviously means that you're going to have to be happy to either make up some custom leads, do some soldering, solder onto the MiSTer for the power, or do some crimping on there. I just wanted to really mention about those details of what you would need to do to put the MiSTer with a USB into this case, because I've made it low so that the USB is on this side without being too cramped all over that side. So like I've said all the way from the beginning, this was made for me with my setup, which is this, and I don't really have an easy way to tell you how to do it. You're going to have to either decide which way the power goes, solder onto the bottom of the MiSTer, make up a barrel jack, or get a very long power wire splitter that maybe goes in the middle and splits out to the two sides. I don't know what's available, so I'll leave those options up to you. But I've confirmed that with that minor modification to the side of the case, that the new USB hub is compatible with my design, and the later I/O boards are also compatible with my design. They were the two factors that I was most concerned about. So on that point, let's go back to my original video. Thank you for watching this video. I will put a link in the description as to where to get the files from. I think I'm going to do a small donation to get the STL files, and then if you want to do anything a bit more custom, then we'll have to talk about it. I will look forward to all of the questions down below, and see you soon. Excuse the hat. I went a bit close with the hair trimming.